Good afternoon. Again, we're looking at a test coming up this week, and I will provide further details. And okay, so in terms of where to begin, okay, in terms of the review, and I do have a class activity 3 set that is up that is due tomorrow night, and part of it, small part of it, okay, is going to be where you're looking at solving an equation in terms of a specified variable. And from the review set, okay, we have with number 91, okay, we have an equation, okay, that is in terms of the x and y coordinate system, whereupon we have 4x minus 3y is equal to 6, and we're looking at solving for y, or expressing in terms of y. And for what we have with this equation, okay, so I'm going to be looking at expressing in terms of y equals. Okay, so looking at isolating the variable y, okay, I can initiate by taking 4x away from both sides. And looking at what we have in the mix, okay, so if I take 4x away from both sides, okay, so we have negative 3y is equal to 6 minus 4x, or negative 4x plus 6. Okay, and there's a future item that's going to be referred to as the slope-intercept form. And looking at putting y by itself. Okay, so if I look at undoing the multiplication by negative 3 upon dividing everything out by negative 3, okay, so we're going to have negative 3y over negative 3, okay, so this is going to be y. And for negative 4x over negative 3, here we have a negative over negative is going to be a positive. And so we're going to have that y is equal to 4/3 of x. And for 6 over negative 3, that is going to be minus 2. Okay, so in terms of how we can express the result in terms of y, well, we have, in this case, have y is equal to 4/3 of x minus 2. And we have also in the set looking at expressing and solving for a specified variable. And we have for number 96. Okay, now this one is a bit tricky. Okay, and here we have fractions throughout. Okay, where we have on the left, okay, we have the reciprocal of a is equal to 1 over b plus 1 over c, and we're looking at expressing directly in terms of b. Okay, all right, so you have fractions throughout, okay, whereupon we have the reciprocals of a, b, and c. Okay, and to write directly in terms of b equals, okay, so we got again a bit of untangling to do. Okay, I'm just going to copy this equation. And so what I can do, just like with what I have done with rational equations, okay, I have gotten rid of the denominators, multiplying by the least common denominator. Okay, so we have the denominators with a, b, and c. And here we're going to have the least common denominator to be a, b, c. Okay, and if I undo the presence of fractions, okay, so I can multiply all the terms out by ABC. Okay, so for what I have throughout, so distributing ABC over all the terms. And we're going to have some cancellations coming up. Okay, so multiplying all three of these terms by ABC. Okay, so we have with the first term, okay, we have 1 over a, okay, and so we're going to have a's are going to cancel, And also looking at it along the lines of cross multiplying, okay, we have b is going to go out, and for the last fraction, c is going to go out. And looking at what is left, okay, so on the left now is going to be bc, and we have is equal to, okay, and this time after canceling out b, we have ac, and from the last ratio we had c to cancel out, so we have ab remaining. Okay, so we had the elimination of the denominators, and again we're looking at trying to solve in terms of b. Okay, and if you notice, we have two terms with the variable b. Okay, so we have on the left we have b times c, and to the right, okay, we have ab. And first of all, okay, we can combine the b terms together. Okay, so I can join bc and ab together. So I can move to AB, okay, and now, okay, we're at BC minus AB is equal to AC. All right, and now, you know, so we have a couple of B terms, and I'm trying to get it down to a single B term. Okay, and for the follow through, okay, now for the difference of the terms, okay, we have a common factor with B, so I can express the difference between BC and AB in factor terms. Okay, so we have B times the quantity of C minus A is equal to AC. And now looking at having B by itself, so if I divide everything out, okay, by C minus A, okay, so we have C minus A to go out on the left, and so solving this equation in terms of B, we have that B is equal to A times C all over C minus A. All right, and again, we most recently have been looking at inequalities along with equations, and there's a part, okay, from the class activity 3 set, okay, that's going to be looking at taking what we have with graphs and writing a corresponding absolute value equation. Okay, and let's say so you have given graphs. I'm going to give just a couple of basic examples and then kind of expand the model. Okay, let's say that if I were to determine the absolute value equation, okay, and we'll say that in terms of a graph. Okay, so I'm just going to put up a number line. Okay, Now let's say if I have a graph, okay, and I'll just say I have a couple of open circles on negative and positive 3. And we'll say those circles, okay, are going to be connected, okay, by a line segment. Okay, and for what we have now, I'm looking at expressing the absolute value equation, or I should say, a better way to put this. In a way, I am dealing with an equation, but what I have more in mind is an absolute value inequality. Okay, so for what we have in determination of the absolute value inequality, now for what I have directly, okay, you have between negative and positive 3. Okay, so neither negative 3 nor positive 3 will be included. And if you notice the circles, you have negative 3 is 3 units to the left of 0, positive 3 is 3 units to the right of 0. And so you have a balance in terms of the absolute values of the negative and positive terms involved. Okay, and so you're going to have your k value equal to 3. And the inequality that springs forth, okay, namely the compound inequality, this is going to correspond to where we have the absolute value inequality. It's going to be whereupon we have the absolute value of x is less than 3. So it's kind of like taking it and working backwards. Again, if like the absolute value of x is less than k, then negative k is less than x is less than positive k. Now, let's say that if I have another bit of activity, and we'll say that we have solid points on positive and negative 4. And say that we're going to have rays to extend, okay, and going in opposite directions. Okay, so our starting points, okay, we have negative 4 on the left, positive 4 on the right. And both negative and positive 4 are equidistant from 0. Okay, so for what we have for the left-hand side, okay, we want to have that x is less than or equal to negative 4. And we have at the other end, we have that x is greater than or equal to 4. So the k value of concern, okay, now like negative 4 has an absolute value of 4, 4 has an absolute value of 4, everything is in balance. Okay, so your k value is equal to 4. And again, for inequalities, okay, that abound, okay, where we have less than or equal to the negative, greater than or equal to the positive, okay, these will originate from absolute value inequalities that will either be in the form of greater than or equal to. So the corresponding absolute value inequality in this case is where you're going to have the absolute value of x is greater than or equal to 4. Okay, so for the first two cases, okay, the k values are automatic. But let's say that if I change things up a little bit, okay, and let's say that for what we have in the third case, and we'll say this time around, okay, let's say that if I have just close points here. So I have a close point on 1 and a close point on 5. And we have these points to be joined, okay, by a line segment. Okay, so for what we have in this particular case, all right, so you got -1 and 5. Now, just looking at it upon face value, okay, so it just has an inequality. So we have -1 is going to be less than or equal to x, which in turn is going to be less than or equal to 5. Okay. And if you notice, I don't have the k value established because I want as much negative on one side as I do positive on the other. And so, if you notice, -1 is 1 space to the left, 5 is 5 spaces to the right. So what I want to do is just kind of shift over and create a bit of a balance. And what I'll do here, okay, so what I'm going to do here is kind of taking what we have in the rewrite case. So visually, okay, so we're starting out with -1 is less than or equal to x, is less than or equal to 5. So what I need to do is just kind of shift over to where I'm going to have the segments, points, limits to be equal in distance from 0. Okay, so if you notice, if I go from -1 and shift over 2 units, like -1 shifting over 2 units, I end up at -3. From 5 shifting over 2 units with the same line segment, I end up at 3. And just looking at the activity, okay, so if I were to deduct 2 from all portions, so we have -1 shifting over to the left 2 units, we have -3 is less than or equal to x minus 2. In turn, is going to be less than or equal to 3. All right, so when I had the inequality with the x in the middle, I did not have the k value established. But now with the shifting of 2 units, by deducting by the amount of 2, I got the k value firmly grounded at 3. Got -k, +k, and k is equal to 3. And for the absolute value inequality, okay, so you have a compound inequality, and I got the endpoints as closed points. Okay, so your k value is going to be at 3. And instead of x, to arrive at the k value, the x had to be transformed to x minus 2. And so for the absolute value inequality, okay, we're going to have the absolute value of x minus 2 is less than or equal to 3. And say just final case here, where you might have a shifting involved. I'll just change the numerical scale on this one. Okay, I don't have 0 in the middle. Now we'll say that we have an open circle on negative 300 as well as 1 on positive 100. And again, we will insert rays that will be going in opposite directions. Okay, so we have for this particular makeup, okay, I have negative 300. Okay, 300 spaces to the left, 100 spaces to the right. So I don't have the K value outright established, okay, but for the inequalities, so right now we got x is less than negative 300, and to the right, okay, so I have that x is greater than 100, and say that if I shift both of these rays, okay, over, okay, so say if I move over 100 units, to the right, and still keeping what I have originally for x, but just rewriting, okay, to where we're going to have the K value to be determined. Okay, so if I were to shift over 100 units, so I'm going from negative 300 to negative 200, to the right I'm going from 1 to 200. And so we're going to have in the rewrite where the inequalities that will point out the K value. Okay, so we're going to have on the left, okay, so you got x plus 100. Is less than negative 300 plus 100 is negative 200. And to the right, I have x plus 100 is greater than positive 200. Okay, and so we have at the one end of the spectrum, okay, we have increasingly negative. The other, we have increasingly positive. And we're able to establish the K value, which is going to be at 200. And again, we're able to identify the K value by adjusting the x to x plus 100. So for the absolute value inequality, instead of just x, again, we transform to x plus 100, where the absolute value in this case is going to be greater than 200.